So for today's video, I wanted to go over wheels, dispelling some myths, as well as going through the history of the Onewheel and why the wheels are manufactured the way they are. So brief overview, when the Onewheel was invented, the V1, several years back, they made it as basic as they could make the Onewheel platform, and it served its purpose as well. Well, shortly thereafter, they released the Plus, and the Plus was essentially a new platform, and the Plus is what all the wheels are fundamentally based on. So over here, we've got a pint wheel, and the same wheel that either a Plus or an XR would have. Now the V1 was released first, then the Plus, then the XR, which was sort of a high-performance version, a souped-up version, if you will, of the Plus. And that seems to be the way Future Motion tends to do things, is they release a model, then they release an updated version of that model before they completely reinvent that segment. So the XR was made before the pint. The XR uses a 6-inch diameter wheel, and the width between rim lips is 6.5 inches. When the pint was released, they made the same 6-inch diameter wheel, but it is only 6 inches between the rim lips. That allows the platform of the board to be narrowed and to run smaller tires with a similar diameter to width ratio. Shortly thereafter, the XR was popular. They sold, I believe, hundreds of thousands of them. They released the GT. Now the GT was similar to the pint, but much larger. Similar architecture though. One of the things that they did with the GT is they changed the offset of the stator within the wheel, and the width between the bearings is wider on a GT stator versus an XR stator. When the GT was released, one of the complaints that many people had was that the diameter of the wheel is 6.5 inches rather than the standard 6-inch diameter that the V1, the Plus, the XR, and the pint used. That 6-inch diameter allowed for the use of just common go-kart tires. When Future Motion released the GT, they made their own 6.5-inch diameter wheel to create their own segment. That 6.5-inch diameter means that you have less sidewall height. That less sidewall height reduces how plush the ride is. So many riders were wishing that they had the same plush ride that they had on their XR, but on the GT. What many riders began doing was to install an XR wheel on the stator from a GT. That allowed the use of a 6-inch diameter tire, or 6-inch diameter rim lip, inner diameter of a tire, to be used on their GT. It solved problems, but it created others. It gave you a softer ride. However, one problem was that the wheel was now slightly offset within the frame of the board, and we made covers to account for the extra stator width, but again, it was offset, and then we had to make carriers that would offset the wheel back center. It became quite a project to install an XR wheel onto a GT. On top of that, the XR magnets have less strength than the GT. N36 to N40-ish is the magnet strength that the XR wheels had. The GT was N40, N42. And so when you put an XR wheel onto a GT, there was a noticeable loss in torque. I began thinking about it, and I thought, you know, people are buying up XR wheels and paying a fortune. They were selling for $900 a wheel at one point, just for the raw wheel with no stator inside. And I realized that we're gonna run out of used XR wheels here soon, and that whole offset issue was a problem. The magnet strength was an issue. So to that end, I decided to, this was 2.5 years back, decided to design my own wheels. One other issue with the stock wheels is that they are cast aluminum. It's less expensive, but also a bit weaker and doesn't dissipate heat quite as well as a machined wheel would. So we start with a billet of aluminum for our wheels, and it's literally a square, a solid cube of aluminum that gets chucked into a lathe and hollowed out to become the wheel that you see here. It's literally machined out of one block. Far, far stronger, which means you can use less material and shave some weight off of it. You can also anodize it then. These cast wheels are powder coated. That powder coating somewhat insulates the wheel and holds heat in. That anodizing allows the bare surface of the metal to be exposed to the air so they can dissipate heat more. Knowing that the GT had stronger magnets than the XR, we wanted to have stronger magnets in our wheels. So we began researching it, and at the time, N48 magnets were about the strongest magnets you could get within a given pricing structure. Currently, N52 are the strongest magnets you can get, and the price has come down a bit. So nearly all of our wheels now come with N52 magnets. Since the GT, now Future Motion has released the GTS. The GTS has, we figure, about N50 magnets. It's hard to tell exactly, but the gauze meter that we've used, we seem to get right around the N50 readings. So our wheels still have stronger magnets even than the GTS. That's a basic overview, but there's some other specifics about these wheels. I mentioned diameter, going from the 6.5-inch Future Motion diameter of the GT and the GTS boards back down to the 6-inch that the XR and the Pint use. That diameter, again, there are many tire options on the market for that 6-inch diameter, go-kart tires as well as one-wheel specific tires, but also 5-inch diameter. In my right hand, the gold wheel is 6-inch diameter, and in my left hand, we've got a 5-inch diameter wheel. Now that 5-inch diameter takes what the 6-inch wheel does in increasing the softness of the ride, and it takes it to yet another level. With a 5-inch wheel, you have a lot more sidewall to work with. Therefore, it rides much softer. It's more carvy. The board has a greater tendency to lean into corners. The wheel itself is even lighter than a 6-inch wheel. So the 5-inch definitely has its place. There are benefits and drawbacks to each. If you're riding in hard chunk off-road, a lot of ruts and rocks, probably a 5-inch wheel is the best way to go, and the corresponding tire that has the tall sidewall, and run a low PSI, 8 or 9 PSI, and you'll get a lot of suspension action, very soft ride. But on the pavement, you do lose some road feel. So personally, I prefer the 6-inch diameter on pavement. That brings up another measurement difference, and that is the width between the rim lips. This is 6.5 inches wide. This wheel here happens to be 6 inches wide. We are unique in the industry in that we offer multiple wheel diameters and multiple wheel widths. We manufacture 5-inch wheels and 6-inch wheels in diameter, each in either a 6-inch or 6.5-inch width. The different diameters and widths allow you to tune the board to ride the way you want. You can run a 5-inch diameter wheel with the narrow 6-inch width and get the softest ride imaginable, or you can run that 5-inch wheel with a 6.5-inch width and gain a little bit more stability back while still having the soft ride. With a 6-inch wheel, you can run the full 6.5-inch width, like this wheel here. You'll notice it's wider. That gives you that great selection of go-kart tires, good road feel, and more stability because you've got wider distance between the rim lips. This wheel is 6-inch diameter, 6-inch wide. This seems to be a very popular wheel among street riders because it gives you that choice of tires, the popular 6-inch go-kart tires. You get good road feel out of it because you don't have too much sidewall between the road and the wheel, but the narrow width allows the sidewall to tuck in toward the rim, and it does offer some more compliance than the full width 6.5-inch would give you. Now, aside from that, we offer different color options. You can mix and match wheel and cover colors. We also, our wheels differ from the factory wheels in another key area, and that is, you'll notice this side cover is removable. And on a stock Future Motion wheel, they also have a removable cover. They have 7 screws on their cover. We have 14 on ours. That is the way you remove the stator from out of the wheel. However, when you flip the wheels over, you'll notice that the future motion wheel is solid on the back side, whereas our wheel has a second cover on the back side. Now, that second cover allows us the opportunity to take advantage of a few things that made one-wheel service a little bit more difficult. One of those aspects is serviceability and replacing bearings. Changing the bearing in one of the stock future motion wheels requires getting all the way down in to press that bearing in place. The dies and the press arm oftentimes are made out of steel, and the wheel will want to suck its way over to that die because you're going between the magnets. You try to put the bearing down in, it'll suck itself over to the magnet. I've seen people break magnets because it'll suck the bearing over and crack a magnet on impact. With our wheels, you just remove the cover and you can press the bearing in and out of that aluminum cover very easily. Also, having a removable cover allows us to put fins on both side covers. Those fins move air, they help cool the wheel, and they also pull air across the axle carrier for additional cooling, and I'll get to that in a moment. Lastly, I wanted to discuss our beadlock wheel. So the beadlock wheel is very unique in a few ways, but the primary thing that you'll notice is that you've got these beadlock rings on the side and a secondary lip on the inside. So I'm going to go ahead and remove this ring and illustrate to you what the primary differences are. A beadlock wheel is what its name would suggest, and that is it is a wheel that locks the bead of the tire between an inner and an outer lip. Now, on a standard non-beadlock wheel, the tire is stretched over the lip of the rim, and then it is now inside the bead lip. And as you pressurize it, the tire will pop over that bead lip and seal against the outer edge of the lip of the tire, or the bead of the tire, and the edge of the rim. Now, on a beadlock wheel, it's completely opposite. You've got an inner lip here. So you can see that there is a lip, there's an inner lip and the outer lock ring, and the bead of the tire fits between those two edges. The orientation of the bead of the tire between this inner lip and the outer lock ring is what gives you that clamping force. Now, there are benefits and drawbacks to a beadlock wheel. The main benefit is the tire can never slip because it's now clamped between two lips rather than just by pressure being pushed against one. So you're clamping the tire all the way around. It can never pop off. It can never slip rotationally. You do not need any tools, any special tire levers to install a tire onto a beadlock wheel. You can just push it on with your hands, and then you put the lock ring on and install the screws around the perimeter. One negative, they're a little bit heavier. Obviously, you've got additional screws, and then you have the thickness of the lock ring. We do offer titanium screws that can save some weight, but it's more cost there as well. It takes more time to put all the screws in, but that time saving, or that added time, is offset by the fact that you're not fighting the tire over a rim lip like you are in a standard wheel and using tire levers and just getting all frustrated. It's easy to pop the tire right over, put the lock ring on, tighten it down. Another downside to a beadlock wheel is now the air is being sealed around the inner edge of the tire bead rather than the outside edge of the tire bead. Manufacturers that make tires are not, they make the outer bead lip on the tire smooth and shiny, so it will seal, it will air seal around the inner lip of the rim. But on a beadlock wheel, the air sealing is not accomplished by this outer locking ring. It is accomplished by the inner ring. So now that inner ring is pushing against the inside of the bead of the tire, which was never meant to have a smooth surface and be airtight. So beadlock wheels will more often than a non-beadlock wheel can have slow leaks through the rim edge. There are products out there that are designed to seal that. Believe it or not, what I found works best is normal window silicone. Just silicone seal it for a window. You put it on this lip does not go on the lock ring. This lock ring has nothing to do with air sealing at all. You would put silicone sealant around this part of the lip where the tire bead presses down on, then you put the lock ring on, and you would thread the screws around. And what I like to do is crisscross pattern, thread the screws down a little at a time to get it to clamp evenly around the bead lip. As of the filming of this video, both our 5 and 6 inch standard wheels are $699. That's with bearings, ready to go. Our beadlock wheels are $850. Now, prices do tend to fluctuate a little bit, and much of that has to do with current cost for magnets and other incidentals when it comes to production. So that's another aspect of this. Now, cost brings up a question that very many people have for us, and that is, why do these wheels cost so much money? I can buy a go-kart wheel for 50 bucks or whatever. Well, there are a number of reasons for that. One reason is just production volume. Go-kart wheels are made probably 10,000 at a time, whereas one-wheel wheels are made a few dozen or maybe 100 at a time. So economies of scale don't quite kick in the same way. Number two is number of components. In our case, we've got the barrel of the wheel itself and then 2 removable covers. A go-kart wheel is just the wheel itself with one center rib to mount it to the hub. Another, and probably the biggest reason, is this isn't just a wheel or a rim, this is half of an electric motor. Half of the motor is the stator, which is on the axle. The other half is the wheel itself. You've got the aluminum wheel, you've got a steel back iron ring inside the aluminum wheel, then you've got the magnets that are epoxied to that back iron ring. So this is half of an electric motor. That process is very, very time consuming. We machine first the hoop, inner and outer machining gets done. The end caps are CNC machined. Then we make the steel back iron sleeve. It's made in 3 separate segments that are installed and epoxied into the wheel. Then they're seam welded on the edges. Then it goes into the lathe, and those seam welds are trued off. Then we lathe additional channels in the back iron and go back and add additional weld deep into the valleys of those recesses that we have machined into the back iron. This is a proprietary process that we developed to make the wheels more reliable, but they also run much more smoothly that way. And once that's done, then we press an arbor into the wheel, which is a tool to hold the magnets in place. We epoxy all the magnets in place, and the arbor expands and holds the magnets tight to the back iron to hold them in place while the epoxy sets. And in between those processes, we do anodizing and drilling and tapping of holes. There is a lot of work to making one of these wheels, and far more work to make a beadlock wheel. Now, one other thing that I want to point out is heat buildup within the wheels. So it is a misnomer that heat is built up in the wheel itself. That's not true. The heat is actually generated in the stator. So the windings for the electric motor of the one wheel are mounted on, wrapped around the stator, which is pressed onto the axle. The vast majority of heat is shed through the axle, not through the wheel. Now, I mentioned that our wheels are anodized rather than powder coated for better heat dissipation, and that we have fins, air cooling fins on the side covers on both sides of the wheel for added heat dissipation. And that is true. There is a small amount of heat that builds up in the wheel, but the majority of heat is built up in the stator itself. And the fins in our side covers work in conjunction with our ice blocks axle carriers in order to further shed heat out of the motor. This is a GT stator. The stator is where the vast majority of the heat is built up within a one wheel. The windings generate the field that drives the wheel in a circle. That field generates heat. That heat flows directly into the axle itself and outward. Now, Future Motion has their frame rails captured to the ends of the axle, and their axle bolts screw into the very end of the axle. And therefore you have heat flowing from the windings on the stator through the axle and into the frame rails. We offer various axle carrier solutions. These happen to be our ice block axle carriers. And but we also make crazy hub axle carriers for the XR platform. And all of our axle carriers wrap around the axle. They slide onto the axle and wrap all the way around it and clamp around the axle. You can see on this wheel, I've already got the axle carriers installed. And this wraparound clamping action not only increases rigidity in the board and strength, but its primary function is to, rather than pull heat just from the end edge of the axle, to actually have a lot of surface area around the axle to pull heat out of that axle and dump it into the heat sink fins on the axle carrier itself, and then from there into the frame rails. Our frame rails also have an open truss design that allows more airflow to get into the axle carriers. Well, I mentioned the fins on the ends of the axle. Those fins, as the wheel is spinning, they throw air outward, which means they're drawing air inward from the center, acting like a fan. So the cooling fins not only shed a couple degrees of heat off of the wheel itself, but they actively move air across the heat sink fins on the ice block axle carriers. And again, you have heat flowing from the stator through the axle and now right through the wall of the axle, and that clamping is closer to the windings, to the heat source as well. So you have a shorter heat path to exit the stator. You've also got now the clamping area that gives you surface area to pull that heat out of the stator axle and into the carrier, and the heat sink fins to dissipate the heat. Then if you couple that with our wheel, with the fan effect of the fins on the covers, pulling air across the axle carriers, you are maximizing your chances of removing heat out of the wheel as much as possible. What we as a company have done is we have taken the aftermarket wheel market as far as really is reasonable to take it. We make wheels in 6-inch wide, 6.5-inch wide. We make wheels that will fit the Pint, the XR, the GT, the GTS, all boards that are out there. We make a wheel for it. We make wheels that are specifically unique to the XR and Pint platform, and wheels that are unique to the GT and GTS platform. And we can tailor a wheel to your needs. If you reach out to us, we can let you know what our recommendation would be based on your body weight, your riding style, the speed that you ride, the type of board that you have, the tires that you like. We offer custom colors, and there's a lot to this. Wheels are a very precise item. They're very difficult to manufacture, and but we are proud to be leading the market in the aftermarket wheel segment. So that's it for me for today, and go ahead and leave any comments in the comments section below. I'm more than happy to answer anything I can for you guys. Thanks a lot.